I'm Dr. P. Jayachitra, Professor, Department of Science and Humanities, Hindustan Institute of Technology. In this presentation, we will learn about lattice. By the end of this lecture, learners would know what is a poset and lattice. That would be able to know the definition of lattices, how to identify whether a given hash diagram and poset is a lattice or not. These things are quite interesting. Let's get started. Partial order relation. A relation capital R on a set A is said to be a partial order relation if the relation is reflexive, antisymmetric, and transitive. If it is reflexive, any element X is related to the same element X. For all the element X belongs to the set A. If it is transitive, the element X related to Y and Y related to X, which implies X and Y both are equal. For all the elements, X and Y belongs to A. If R is transitive, X related to Y and Y related to Z implies X is related to Z. For all the element X, Y, Z belongs to the set A. If you take any element 1, 1 is related to itself. If you take the element 1 is related to 2 and 2 is related to 3, then we can say 1 is related to 3. In this case, it satisfies reflexive and transitive. If X related to Y and Y related to X means X and Y both are the same elements. So the set together with the partial order relation is called the poset. So the standard relations are that all relations are divides less than or equal to and subset relations. Hash diagram is a graphical representation of the relation of elements in the partial order set. If P is related to Q, then the 2 points P and Q will be joined by the line segment. If the element P is less than Q, then P will appear in the bottom of the hash diagram and Q will appear in the top of the hash diagram. Same example to better understand. Hash diagram for the poset 3, 4, 12, 24, 48, 72. The relation divides relation. For this poset, the hash diagram is based on the relation. We have to draw the hash diagram. See the hash diagram. 3 divides 12, 24, 48, 72. 4 also divides 12, 24, 48, 72. So 3 is the minimum element, but 3 does not divide 4. So we have to write 3 and 4 in the bottom of the hash diagram. So both divides 12, 24, 48 and 72. So here 3 does not divide 4, at the same time 48 also does not divide 72. So there is no edge between 3 and 4 and between 48 and 72 respectively. So this is the required hash diagram for the given partial order set. The definition of lattice. A lattice is a partial order set in which every pair of elements contain both greatest lower bound and least upper bound. Let's see an example for lattice. We have to determine whether the given hash diagram is a lattice or not. We know that the hash diagram is a lattice if every pair of elements in the hash diagram contains both greatest lower bound and least upper bound. So for this hash diagram, we have the incomparable pairs are 2, 3 and 4, 6. Except these two pairs, remaining all elements are comparable pairs. So we know that the comparable pairs always contains greatest lower bound and least upper bound. So to check the given hash diagram is a lattice, we have to consider the incomparable elements. So for this hash diagram, the incomparable elements are 2, 3 and 4, 6. For 2, 3, we have to find the greatest lower bound and least upper bound. To find the greatest lower bound, trace the path downwards. So if we trace the path from 2 and 3 downwards, it meets at 1. So 1 is said to be a greatest lower bound of the path 2, 3. To find the least upper bound, trace the path upward. From 2 and 3, if we trace the path upward, it meets at 6. So 6 is said to be a least upper bound of the incomparable pair 2, 3. So for this pair 2, 3, it contains both greatest lower bound and least upper bound. Similarly, we have to consider the next incomparable pair 4 and 6. To find the greatest lower bound, trace the path from 4 and 6 downward. So it meets at the point 2. 2 is said to be a greatest lower bound. To find the upper bound of the pair 4 and 6, trace the path upward. It meets at 12. 12 is said to be a least upper bound of 4 and 6. So for the incomparable pairs 2 and 3, 4 and 6 contains greatest lower bound and least upper bound respectively. Therefore, the given hash diagram is a lattice. Here is another example. Our aim is to determine whether this hash diagram is a lattice or not. For this hash diagram, there are two incomparable pairs. One is B, H and another one is D, F. Since there is no H between them, consider the incomparable pair B and H. So, to find the least upper bound, trace the path from B and H upward. It meets the point at A. Therefore, A is called least upper bound of B and H. To find the greatest lower bound, trace the path from B and H downward. So if we trace the path, there is no common point. Therefore, greatest lower bound does not exist. Therefore, the given hash diagram is not a lattice. Determine whether these four sets are lattices. For these four sets, we have to draw the hash diagram and then we will determine whether it is a lattice or not. First, we will consider the first four set 1, 5, 25, 125. The relation is divides. Let us draw the hash diagram for this four set. See the hash diagram. 1 divides 5, 5 divides 25 and 25 divides 125. It's the total order because every element in this hash diagram is comparable. Therefore, it is a lattice. The poset is 1, 3, 6, 9, 12. The relation is divides relation. For this partial order set, the hash diagram is the pictorial representation. 1 divides 3, 3 divides 6 and 9, 6 divides 12. For this diagram, 9 does not divide 12. Therefore, there is no edge between them. To find the lattice, we have to consider the incomparable pair from this hash diagram. So for this hash diagram, incomparable pair is 9 and 12. To find the greatest lower bound, we have to draw the path downward from 12 and 9. It meets the point at 3. So 3 is called the greatest lower bound. To find the upper bound, we have to trace the path from 9 and 12 upward. So we cannot trace the path upward. So therefore, there is no least upper bound for this hash diagram. least upper bound does not exist. Therefore, the given hash diagram is not a lattice. Consider the poset Z is a set of all integers. The relation for this poset is less than or equal to. For this poset, the pictorial representation is 1 divides 2, 2 divides 3, 3 divides 4, it goes up to infinity. See the hash diagram, it's a total order. Every elements are comparable. Therefore, it is a lattice. This is an infinite lattice. Consider the power set of A, and the relation is a subset relation. We have to check whether the power set is a lattice or not. Here we are talking about power set of some set A. Let A be the set 1, 2, 3. The power set of A is a subset of A. Empty set is a subset of 3 elements. Singleton set 1, 2, 3, and double set 1, 2, 1, 3, and 2, 3, and the whole set 1, 2, 3. This is the power set of A. We have to draw the hash diagram for this power set. Phi is a subset of all the set. Here the relation is a subset relation. So we have to place phi in the bottom of the hash diagram. 1, singleton 1, singleton 2, singleton 3. These three are the subset of 1, 2, 1, 3, and 2, 3 respectively. 1, 2, 1, 3, 2, 3 are the subsets of 1, 2, 3. So we have to place 1, 2, 3 in the bottom of the hash diagram. Here the incomparable pairs are 1, 2, 2, 3, 1, 2, and 1, 3, 1, 3, and 2, 3. For every pair of elements in the incomparable pairs contains greatest lower bound and least upper bound. Therefore, the given power set is a lattice. I hope this is clear to you that how to determine whether these posets are lattices or not, and how to determine whether a particular hash diagram is a lattices or not. Thank you for watching this video.